Hello everyone, in this video we are going to create this dynamic effects of sticky notes using the geometry nodes and class simulation. So let's get started. So let's add the plane. Then we're going to rotate this plane along the x-axis in the edit mode so that we are facing this plane, okay, in the front side. Then we're going to add the geometry nodes. So first we're going to create the sticky note with the geometry nodes. You can also do that manually, but in this case I'm going to create that with the nodes or kind of fully procedurally. Okay, so let's first add the C line. So we have this line, then it should be in the negative Z axis, so that we have this origin at the top of this sticky note. Okay, then we're going to add the resample node and change that to length, and also add the value node. Then we're going to add the curve to mesh node, and here we're going to also add the C line for the profile, and this should be negative 0.5 for the x-axis and plus 0.5 for the x-axis on the end side, and the z should be 0. So we have this, and then we're going to add the transform geometry node so that we can define the width of this sticky node, and with this we can define the length of this sticky node. Okay, and then we're going to also duplicate this resample node, and we're going to resample the profile curve and also connect this to this. So let me go to the wireframe and also increase this. So with this we can control the resolution of this. Okay, maybe 0.075, and we're going to decrease the size of this sticky node, something like that, and also decrease the width, yeah, something like that. Okay, we have this. Next we're going to bend this. Okay, let me go to the side mode. So we're going to bend this slightly. Okay, so let's add the set position node. Okay, and here we're going to add the v scale node, and then we're going to connect that to the normal. Okay, and for the scale we're going to use the spline parameter or spline factor to define this scale. So let me capture that before this node, and also add the spline parameter node, and here we want to capture this factor, and let me show you this. So this is the factor along this curve, and if we capture this before this curve to mesh node, we have this for the mesh as well. So here we're going to add the float node to define the shape, and then we're going to also add the multiply node to control the scale. So right now it is pushing in the backward direction, so that is because of the normal. Let me show you the face orientation. See, we have this wrong normal, so let me flip this, flip faces. So now it is pushing along the front side, so that's what we want. So we have this, so we're going to make this something like this. Okay, maybe something like that, and with this we can control the overall scale of this bend, maybe 0.1. Okay, something like that. And another thing we would like to do is that we're going to store an attribute to this, so that we will use in the class simulation for pinning. Okay, so let me add the store attribute node. Okay, and here let's call this group, and then we're going to add the end selection. Let me show you the selection. So we have this, and we only want from the start side, so let's add that. So with this you can basically control the selection extent from the start side. Okay, so we have this, and that will be also available after the this curved mesh node. Okay, okay, so we have this. After that we're going to also add the set material node, and we're going to add the material to this. It's called the node. Okay, add that here. So this is our sticky note setup. Okay, so next we're going to add these to this plane. we're going to add the distribute points node. Then we're going to add instance on points, and let's plug that into this. Now we have these sticky nodes, and in this case we want this to be Poisson disk distribution. So with this we can define this distance minimum between these points. So that is really handy. Maybe something like that. So we have this. Okay. So next we need to realize this because we need the actual geometry for the cloth simulation. Another thing we can do is that we can basically define the rotation and scale of these sticky nodes. So let's add the random value node, and we only want to randomize the y rotation, maybe 0.2, and this should be negative 0.2. Okay, here we can also randomize the scale, but in this case I want the same scale. So next we're going to add the cloth simulation to this. So we have this, and let me show you the settings of this. So first we want the 10 quality steps and 0.05 vertex mass, and here this should be 50, 50, and this should be 2 or 3 depending on the bending amount you want for that sticky node. And this should be 10, 10, 10, and this is 0.25. Okay. And now here we need to define that pin group, but see, we can't add that. Okay, that is because it is generated inside the geometry nodes, and right now Blender doesn't allow us to use that. So we need to add some hack to that. So let's first create the group with this original geometry. So this geometry, so we have this group with the original geometry, and let me go to the modifier and also go to the cloth simulation, and here we can define that group. So but if we run this, see, all these sticky notes are falling. It means this group is not working. Okay, so we have to basically combine this group that we have created here for the sticky notes with the group that is generated by this original geometry. Okay, to combine that, basically we have to combine this geometry. So here we're going to add the join geometry node, add that to this, and now we have this. So now if we run this, see, these sticky notes are not falling. Okay, so now this group that we have created here, it is working. Okay, we can also modify that after this realize instance option. We can add the store named attribute node, select the group, and let's define one here. We have this, we can make that 0. See, they are falling. So now basically we can animate this. Okay, another problem is that we don't want this original geometry. Okay, so this geometry, so we need to delete that. So we can do that. We can add the store named attribute node, change that to boolean, and add an attribute delete. Okay, and then we can add the delete node and select the named attribute node and select that delete. Now we don't have the original geometry, but the group is working fine. Okay, see, with this hack you can use the group that you have created inside the geometry nodes for the physics simulation, like in this case cloth simulation. Okay, so let me hide this and also hide that. So let's add a frame for this. So this is like join group setup. So here we're going to modify this group. Okay, so let's add the set position node, and then we're going to generate the mask based on these points using the proximity node. Change that to points. By the way, you can use the fall of nodes if you have the free version of the extra nodes, but in this case I'm creating the mask from scratch using the nodes. Okay, we have distance, then we can add the map range node, and let me show you that for the instances. So that is really handy to modify this group based on the instances instead of the real geometry. It is 0 because of that distance. So now if we push these points along the y-axis, see, this mask is changing, and that will be more clear if I also join these points with this geometry. So these are the points, and if we push this along the y-axis, see the mask is changing. Let me show you that for this real geometry. So we have this, but in this case we have this kind of gradient that may create a problem when we want to pin these sticky notes. That's why we want to first capture this mask on the instances, and then we're going to modify this group. Okay, so we're going to add the capture node, and we want to capture that based on the instances. Plug that here, and we can plug that to the group. So let me make this 0. So we have this, and we can push that along the y-axis. Now all these sticky notes are falling, and here we can also make this 0.25 so that we have faster fall off. So now we're going to animate the position of these points. First we're going to add the xyz node, and here we want to animate the y-axis. So let's add the map range node, and here we're going to add the time frame. So we want to move these points, let's say from 10 frame to 15th frame, from 0 to let's say maybe 5. Let's also join these points just for the visualization. We have this. See, it is working. Now we can randomize this start and end frame. So we can add the random node. So let's say we have different start frame, maybe from 10 to let's say 60, and then we can add some value to this, let's say 5 frame, and we can use that for the end. Okay, so this is kind of duration, and this is the start frame. So now we have something like this. Okay, nice. So let's first add forces to this, and then I'll show you how to define the shape of these sticky notes based on the curve. Okay, so let's add wind force, something like that, maybe slightly in this direction and also pointing slightly downward, something like that. And this should be really high, maybe 500. And I think we need to decrease the gravity, maybe 0.25. Okay, so let's increase the wind, maybe 2000. And also add the turbulence, maybe 500. And I'm going to animate the rotation of this turbulence, 30. We can put this somewhere here and also move this down. Okay, and another thing we can add is the self collision. Let me go to the collision tab. We can increase the quality step to 4. Add this self collision 0.0025. Okay, this also 0.0025. So now let's go to the edit mode of this plane, and we can increase this so that we have more sticky notes. Okay, so if there is some collision, the self collision, you can increase this distance maybe 0.005. And now let's define the shape based on the curve. So first we're going to add a curve, maybe a circle, rotate this and something like that. So in this case, we don't want to affect the sticky notes that are near to this curve. Okay, so let's bring that curve here. Now change that to relative and then add curve to mesh node. Okay, and then we're going to add the proximity node, change that to edges, and here we're going to add the node called the greater than. So let me show you that for the points. So we have something like that. So we don't want to move these points, okay, so that are black. So let's plug that to the selection of this set position node. So now we have something like this. See, these points are not moving, so we have some kind of shape. So let me hide this, the points, because that we don't want, and let's rerun this. Nice. And another thing you would like to do is that the collision with external object. So let's add a plane, slightly move in the negative y-axis so that we don't have intersection with these sticky notes. Maybe slightly bigger, something like that. Then we can subdivide this. Okay, so next we need to put this in a collision collection. Okay, and also we're going to make this as a collision object. Okay, in the soft body and cloth, we need to decrease this thickness outer to 0.0025, so that we have defined in the cloth simulation, and there is no inner because this is a 2D object. Okay, and we can also decrease the friction maybe too. So next in the cloth simulation, we can select that collection, so that collision collection that has this plane. So now let's see this. Let me refresh this simulation. See, they are colliding with this plane. Nice. Another thing we can do is that we can also add some random attribute to these sticky notes so that we can randomize the material or color of these sticky notes. Change that to instance because we are storing the attribute at instance domain, and let's call this ins random. Okay, and here we can add the random node. Okay, so let's go to the material and then we can add the attribute node, add ins random, and with this we can basically randomize the color of these sticky notes. See, we have this random color. We can, let's say, maybe so we have this. Nice. And another thing you can do is that you can also store the mask based on this curve that we have created here to these instances and use that for the color variation. This is it, and this is how you can create this dynamic sticky note effect. So here we have created the sticky notes, then we scattered them on the plane, and after that we have animated their group, the pinning group, based on the proximity of the points. So this is how you can create the dynamic vertex weight using the geometry nodes and create amazing effects. You can get this project file from my Patreon page. So this is it. I hope you learned something from this video. So if you like, then please like the video and subscribe to my channel for more updates. So thank you for watching. See you in the next video. Happy noding. Bye.